Have you ever attended a dissection? My recollection of my first time is actually pretty fresh, and I clearly remember foreseeing my possible skin reaction to the autoptic room and being worried about the smell of formaldehyde. I could have bet that I would have felt sick. The truth is that when you enter the room, there is nothing but the rituality and the grandeur of the process, the questioning of what you know about the anatomy and the discovery of new things. What struck me the most is that when you are there, you get access to a large amount of information that you cannot retrieve from books or papers. That is the access to the geometrical relationships between the anatomical structures, between white matter fibers, and between these fibers and the cortex. There is this passage from Leonardo da Vinci's notebooks on anatomical drawing that perfectly describes what I mean. If you wish to note roughly the parts of a man after he has been dissected, you must either turn him or your eye so that you are examining from different aspects, from below, from above, and from the sides, turning him over and studying the origin of each limb. And in such a way, the natural anatomy has satisfied your desire for knowledge. And again, and you who say that it's better to look at an anatomical demonstration than to see these drawings, that is me in this instance, you would be right if it were possible to observe all the details shown in these drawings in a single figure. Indeed, what you materially bring home after a day of dissection is a series of pictures, and although they're very stunning and informative, once you finish taking your shots, there is no going back. So let's say that on day 2, I want to investigate the connectivity between the angular gyrus and the middle frontal gyrus. From this picture, I could get a representation that is similar to this one, with a good exposure of the main body of the bundle, but still I can only speculate on the overall cortical terminations of it. So if it is my lucky day, I might have a couple of other shots that allows us to better investigate its cortical termination, but still it is difficult to get all the information that I need in a single picture. Still, we need to remember that if we are talking about connectional neuroanatomy, we do have a technique that allows us to have all this information in a single 3D representation. Tractography is great, and we can make a list of its bright sides as well as its dark sides. But what is of interest for me in this instance is that while it is a great technique that allows us to investigate a multitude of things, since it is an in vivo technique, it is based on an indirect measurement, and therefore it only provides a proxy for brain connectivity. In the last decade, great effort have been put into developing the best tractography algorithm possible. But what does best eventually mean? We want our tractographic reconstruction to be as close as possible to the real anatomy. What is normally done is that we take our tractographic bundle reconstruction in tractography and we draw its correspondent into a 2D picture of dissection. But here we go back to our original problem. So on the side of tractography, we have a 3D representation, while on the side of dissection, I have a 2D representation, and it is difficult to have all the information that I need in a single picture, as said before. What if I tell you that this is now the past, and we now have the possibility to have both types of information within a 3D framework? I would say that this is a great time to introduce our framework that is the BraDiPho. BraDiPho stands for Brain, Dissection, and Photogrammetry, because it's literally a story about brains that are prepared according to our group's adaptation of Klingler preparation technique, layer by layer cortex-sparing with dissections, and photogrammetry. So for each layer of dissection, the brain is put into this light box and on a rotating plate. For each 3-degree rotation, a shot is taken from both cameras and from 2 different points of view. All the pictures that we take then need to be aligned, and the metrics need to be set on this picture so that we can get a point cloud, and then from the point cloud, we can move to the mesh. On the mesh, we can then project our texture coming from the picture, and we have a 3D model of each layer of that section. If we zoom into these models, we see that the texture is so good that we can actually follow the fibers from cortex to cortex. But we also took a step forward. So since we have the MRI of the specimen that is acquired before dissection, we have, first of all, the possibility to put all our 3D models of the different layers of dissection into this space. But also it follows that we can take information coming from a second radiological space, for example, MNI, and bring it into the specimen space. So for the first time, we have a representation of tractography and ex vivo dissection within the same space. On top of this, we produce a series of annotation that allows us to follow the cortical landmarks as the dissection proceeds, but also subcortical annotations that allows us to highlight the different connections of interest for us. So speaking about connections of interest, we tested the applicability of BraDiPho on the reconstruction of the structural connectivity of the angular gyrus as defined by a recent work by our group. I want to show you two cases. So let's consider this connection that is registered into the specimen space and that connects the middle frontal to the angular gyrus. We first need to find an epoch of dissection in which this connection is present. For example, this one. We identify the cortical landmarks, and then we draw our connection as it is present in the real anatomy. Once we register our tractographic reconstruction of the bundle in the specimen space, we see that what we drew actually represents the most ventral, lateral, and shorter part of this connection. But if we remember correctly, our bundle's reconstruction, we also had a part of the bundle that was going more anteriorly in the MFG, and we get this connection on a deeper layer of dissection, that is this one. So in this case, we do have a complete validation of this pattern of connectivity between the angular and the middle frontal gyrus. But let me show you a second example and give you a different perspective on this. So in this same layer of dissection, we do have a second connection that goes from the angular gyrus to the superior frontal gyrus. That is this one. If we register our tractography within the specimen, we see that our tractographic reconstruction does not match exactly what we get. It seems to be like a more dorsal, shorter connection between these two cortical areas. Thing is that while dissection is being to the single subject and to the approach of dissection, the tractography that we registered here comes from 39 subjects concatenated. Therefore, we would expect it to be more comprehensive as possible. So what does it mean? It means that since there are probably difficulties in tracking and other related issues with tractography, we now have a real anatomy-based information that we can then give to our tractography to have a more anatomically reliable reconstruction. I would say that it's time for wrapping up, and I would like to say again what I hope are the take-home messages of this topic. So first of all, for the first time, we have a space in which we can directly compare in vivo tractography and ex vivo dissection in a 3D reconstruction. Then the two examples that I just showed you, I hope that they showed how it is possible to use anatomical information to validate in vivo tractography, but also how we should use this information to make our tractography more anatomically reliable. And then the part about the annotation, it's good because it allows us to preserve the cortical landmarks as we proceed for the dissection, but it also paves the way to a possible quantification framework. So let's say that the annotations that we make ex vivo can then be used to take measurements or then be brought back into the MNI space, for example, and have different applications. Lastly, that's something that we are aiming to do is that since, as I said, dissection is binned to the single subject variability, and then also to the dissection approach, we are planning to increase the number of the specimens. For now, we have 12, and to vary the type of dissection approaches. Lastly, I would like to present you our website. We produce a website presenting our journey between merging in vivo and ex vivo and vice versa. So on this website, you will find, first of all, an interactive navigation window in which you can play with 2 photogrammetric models, one left and one right, with a low resolution online. Then a data catalog explaining all the data that we acquired and produced. Of course, the methodology section that will show you how we did all of this. Most importantly, probably, a part in which you can download for free the data from 2 hemispheres. Of course, you need to sign to accept these terms and conditions. And then you can download the dissection, the annotations, and the tractography data. Then a tool part in which you will be able to register online your own Bandos reconstruction. So you upload the TRK and the anatomical image, you download your tractography, and then you can use it locally on Cloud Compare with the specimens, of course. Then the last part, we produced a series of preps with which you can interact with the specimens. Finally, I would like, of course, to thank all the contributors to this project and all our partners. Thank you, and I hope to see you in Montreal.